Okay, next I want to talk about Earth-Sun relationship. So the relationship of the Earth to the Sun. Now, this is a figure kind of describing some of this. This is something called the plane of the ecliptic. It's an imaginary flat plane on which the Earth is moving around the Sun. A couple of things about the orbit of the Earth around the Sun. One is that it's not always at the same exact distance. This is exaggerated somewhat, but sometimes we're a little bit closer to the Sun, sometimes we're a little bit further away. So in July, we're a little bit further away. In January, we're a little bit closer. It's not a perfect orbit, but that's really not that significant. What is more significant is the fact that the Earth is tilted relative to this plane of the ecliptic. It's tilted at 23.5 degrees. So if you look at the equator here, it's not sitting right on this plane. It's tilted kind of upwards at 23.5 degrees. And as it moves its way around during the opposite time of the year, it's tilted in the other direction. And that tilt of the Earth is what's going to cause the seasons, not the distance from the Sun. So let's talk about how the Earth moves. We have a couple of different types of movement of the Earth. We have the spin on the Earth on its axis. Its axis is the North and South Pole. So it spins towards the east. That's why the Sun appears to rise in the east. And that gives us our 24-hour day and night cycles. And the second movement of the Earth is its revolution around the Sun. These are 1 year-long movements of the Earth moving around the Sun. And this is going to cause different amounts of sunlight to strike more directly at different latitudes over the course of the year. Now, one thing I'll highlight is the Earth is going to have a daytime side and the Earth is going to have a nighttime side. And there's an imaginary circle dividing that called the circle of illumination. So the circle of illumination divides the day side from the night side. Right? Now, we mentioned this plane of the ecliptic. This is an imaginary flat area on which the Earth is moving around the Sun. And the Earth is tilted at 23.5 degrees from that plane. And I want you to note that number, 23.5 degrees. We'll be talking about in just a moment. And that tilt of the Earth as it moves around the Sun is what causes seasonality. It changes the angle at which the Sun is hitting any given latitude during the course of the year. And it also affects the length of days, whether we have long days or short days. So in the summer we have longer days, winter we have shorter days. So let's take a closer look at that. And so so as the Earth is moving around the Sun, I put two different suns here to kind of show two different times a year. The Earth is tilted at 23.5 degrees. And because of that, let me jump to the next figure. In late June, around the 21st, 22nd, it's called the summer solstice, and the Sun is shining directly over this latitude. It's called the Tropic of Cancer, which is 23.5 degrees north. And then if we kind of imagine it going to the winter time in late December, now the Sun is directly over the Tropic of Capricorn at 23.5 degrees south. And every time in between there, the Sun is going to be directly overhead somewhere within these areas that we call the tropics. Now, once we move outside of the tropics, the Sun is never directly overhead. Up here in Fresno, where we are, it gets its closest in late June. That's when we have the shortest sun angles, and then it gets the longest angles are during late December. We have our very short days, and you'll notice the Sun looks very low in the sky. So here's a marker showing the Tropic of Capricorn here, going through Australia. And so a couple things I'll highlight. Notice the latitude of the Tropic of Cancer. It's at 23.5 degrees north. That's the same as the tilt of the Earth. If you look at it, because the Earth is tilted in that direction, the 23.5 degrees coincides with that tilt of the Earth. And so it's 23.5 degrees because it is at a 23.5-degree angle from the equator. Now, maybe less obvious is the Arctic and Antarctic circle. These are the areas that can experience 24 hours of daylight or 24 hours of darkness, depending on the time of year. Let me go back one. So during the summertime, in late June, this whole area can have sunlight. Whereas in December, this area would be in total darkness. And when it comes to the latitude, 66.5 degrees, if you do the math, that's 23.5 degrees from 90. So if you take 90, you subtract 23.5 degrees, that's where you get 66.5. And latitude really also affects seasonality, that in the tropics, the areas that receive that direct sunlight, these are the parts of the earth where the sun is directly overhead. And in summer it's up here, and winter it's down here, and then it crosses back and forth in between. And these places are hot year-round, and it's really outside of the tropics that we really have proper seasons like winter and summer and so on. So you should know and be able to identify these places on a map. The equator at 0 degrees, the Tropic of Cancer at 23.5 degrees, the Tropic of Capricorn in the south, 23.5 degrees south, the Arctic Circle at 66.5 degrees north, and the Antarctic Circle at 66.5 degrees south. Because those create these different zones. We have the tropics here between the Tropic of Cancer and the Tropic of Capricorn. We have what's called the mid-latitudes between the tropics and the Arctic Circle, or the tropics and the Antarctic Circle. And then we have the polar regions above the Arctic Circle or below the Antarctic Circle. And the polar regions are those regions that can be up to 24 hours of daylight or 24 hours of darkness, depending on the time of year. So here's a couple of other ways of viewing it. June 21st is when we have this summer solstice, when the sun is directly over the Tropic of Cancer. Whereas December 21st is when we have the winter solstice, when the sun is directly over the Tropic of Capricorn. And then between there are equinoxes, when the sun is directly over the equator. This figure shows it maybe a little better. So here in December 21st, the sun is directly over the Tropic of Capricorn. The North Pole is in complete darkness, and the southern polar region is in complete daylight. During June 21st, here the sun is directly over the Tropic of Cancer. The northern polar region is in complete daylight, and the southern polar region is in complete darkness. And then in between we have an equinox, and when the equinox is happening, everywhere on Earth, all latitudes receive an equal amount of sunlight. And the days are of equal length. Everywhere is 12-hour days. So equinoxes are equal, the solstices are the extremes. And this is one reason why this is the prime you have differences in temperature differences, is because of the angle from the sun. So here during an equinox, when the sun is directly overhead the equator is receiving 100% of the direct sunlight. But as your angle changes, as you move further north, it drops to half of that at 60 degrees north, and then down to 0, where it's just kind of crossing right over the top. On a more local, and so here during a summer solstice, the sun's vertical rays are directly over the Tropic of Cancer, and then the oblique rays are in the southern hemisphere. And you notice these are, if you look at that's very concentrated, and this is very spread out. So if the sun is not hitting, if there's not as much energy in this spread out area, it's not as concentrated as this area. Maybe a better way is looking at it is, if you're getting more direct sunlight, this is 1 square meter of sunlight, and on the ground it's striking just over 1 square meter on the ground. But if you look at this more oblique angle, more of an angle, 1 square meter of sunlight is spread over like 2¼ meters on the ground. So it's less concentrated and will heat up less. Here's a couple of images here. This is a picture at 11:30 p.m. in the Antarctic, meaning the Antarctic being near the South Pole. So you might ask yourself, is this going to be in December or is this going to be in June? Give me time to think. Now, because it's in the southern hemisphere, this would be in December. This would be in the time when they are receiving the majority of the sunlight, and the northern hemisphere would be in winter. Which is another thing I should note, is that, you know, you should always kind of bear in mind that whatever is happening where we live in the northern hemisphere, the seasons are always going to be the opposite in the southern hemisphere. When it's our summer, it's their winter. When it's their, and likewise when it's their summer, it's our winter. In the polar regions, you can have the phenomenon known as the midnight sun. This is where the sun will go low in the sky, but never quite set. And it'll just start coming back up. And so and if I asked you, would this be in the northern polar regions or the southern polar regions, you may not know, because it would depend on what time of year it is. In the north, this would be in June. In the south, this would be in December. Now in Fresno, I took a picture of this during the summer solstice. And in Fresno, we never have sun directly overhead. This is as close as it gets, and I took a picture of the shadow of this post, and it's a pretty short angle. If I were to take a picture in the wintertime, it would be a very long shadow cast by this post, because the sun is just sort of back here. But here it's pretty high in the sky. So this angle is at its shortest now, but it will never shrink to nothing. There's always going to be a little bit of a shadow cast by the sun, because it's never directly overhead where we are, because we're outside of the tropics. Now, ancient civilizations were very interested in the seasons, measuring solstices and equinoxes. This is a pyramid in Chichen Itza, Mexico, called El Castillo. And one thing unique about it is that it's built so that during an equinox, one particular day of the year, the building casts a shadow that will actually create a snake body, and then this is the head of the snake. And so it's built at such an angle that it will perfectly cast a shadow on one particular day of the year. And one reason why, you know, people were so interested in, you know, the sun angle, is people had to know when to plant crops. So these are ancient, you know, agricultural societies. They had to have some ways of keeping track of time. It's like, well, I guess that snake is filling in pretty good there. We better go plant our corn or whatever, or harvest it, or whatever the case may be. And lastly, I want to show you this. This is going to be on the exam, our first exam. This is actually the figure from the exam. You're going to have to be able to identify the equator, where it is, the Tropic of Cancer, B here, the Arctic Circle up here, the Tropic of Capricorn down here, and the Antarctic Circle down here. You also might need to answer questions such as, which one of these lines receives the most direct sunlight around June 21st? That would be up here in the north. That would be the Tropic of Cancer. Maybe which one of these receives the most direct sunlight around December 21st? Well, that would be down here, Tropic of Capricorn. Which one of these receives the most direct sunlight around March 22nd or 23rd? I won't try to trick you with the exact day. I forget myself, but it's late March, late whatever. So in the one in March, always late March, it'd be an equinox. It would be here. Or late September, also an equinox. It would be directly over the equator.